Computational thinking is a systematic approach to solving problems, particularly those that can be tackled using computers. It is built upon three main components: decomposition, pattern recognition, and abstraction. These elements work together to enable the efficient understanding and resolution of complex tasks by breaking them into manageable parts, identifying commonalities, and simplifying the essential aspects of the problem. Computational thinking is not confined to programming or software development. It is a universally applicable skill that enhances problem-solving in many areas, including mathematics, science, engineering, and everyday decision-making. Decomposition is the first and arguably the most crucial step in computational thinking. It involves breaking down a complex problem into smaller, more manageable parts or sub-problems. The purpose of decomposition is to make a problem less overwhelming and more approachable by focusing on individual components that can be tackled independently. Each smaller part can then be analyzed, solved, or addressed separately, allowing for a more structured and systematic approach to the overall problem. For example, if the goal is to design a computer game, the problem can be decomposed into subtasks such as designing characters, developing game rules, creating the user interface, and coding the underlying logic. By isolating these elements, the complexity of the entire project is significantly reduced. Decomposition is particularly valuable in computing because many tasks involve intricate systems with numerous interdependent components. By dividing the system into its constituent parts, developers and problem solvers can focus on specific areas without being overwhelmed by the whole. For instance, when building a website, one might decompose the task into designing the layout, implementing navigation, creating content, and ensuring functionality across devices. Each of these tasks can then be addressed using specialized tools, techniques, or expertise. Another advantage of decomposition is that it allows for parallel processing of tasks. Once a problem is divided into parts, different team members or systems can work on these components simultaneously, accelerating the overall process. Additionally, decomposing a problem often reveals patterns or structures that can be reused or applied to other problems. For example, if a certain method for handling user input is devised for one project, it might be adapted for another, saving time and effort. In computational thinking, decomposition not only simplifies problem-solving, but also lays the groundwork for the other two components: pattern recognition and abstraction. By breaking a problem into smaller parts, patterns and regularities become more apparent, enabling better understanding and optimization. Furthermore, abstraction, focusing on the most relevant information while ignoring extraneous details, becomes easier once the problem has been divided into well-defined segments. Decomposition is an essential skill for anyone engaged in computational thinking, providing a framework for approaching complex problems with clarity and efficiency. By breaking problems down into smaller, manageable parts, it fosters a deeper understanding and enables effective solutions that might otherwise seem unattainable when viewed as a whole. This methodical approach not only enhances computational work, but also serves as a powerful tool for addressing challenges across diverse domains.